Hi all, welcome to CodAffection. This is our second video of this series implementing user authentication and authorization using ASP.NET Core Identity within a Web API project. In this particular video, first of all, we'll start with discussing all the things that you want to know as a prerequisite to user authentication. And then we'll implement the user authentication in ASP.NET Core Identity using JSON Web Token. In previous video, we have given a detailed introduction to ASP.NET Core Identity and we have implemented user registration. So if you haven't watched that video, I strongly recommend you to watch that first before watching this. I have given the link inside the video description and inside the first comment of this video. From now onwards, the discussion on the framework ASP.NET Core Identity could be split into three parts. So first of all, we have client. It could be any API Explorer like we used previously, Swagger UI, or it could be Postman, or it can also be client-side applications developed in Angular or React. So whatever that is capable of making an API request into the Web API project. And then we have the Web API itself developed in ASP.NET Core. And finally, we have the database. In this project, we are using SQL Server DB. Now for better clarity, I will split the Web API into two parts. So first of all, resources, you could think of them as various web methods inside the Web API. And then we have the framework ASP.NET Core Identity. Now in previous video, we have discussed user registration, in which we have created a new user or new identity into the identity solution that we have. So from the client side, we have made a post request into this URL. Along with the user details, we also pass user credentials like email and password. And the respective Web API method handle the request by saving the pass user details along with the credentials into the SQL Server DB with the help of ASP.NET Core Identity Manager User Manager. Now as a next step, we are going for user authentication. So let's start with the definition itself. Authentication is the process of determining a user's identity. So during the authentication process, the Web API expects the credentials which is first passed to the Web API during the user registration process. Now it is the responsibility of the Web API to check whether there is an identity with the given credentials. So that's what we are going to implement as part of user authentication in this video. So the process authentication involves authenticating a user and responding when an unauthenticated user tried to access a restricted resource. So as a first step towards implementing it, first of all, we have to add the respective service into this iService collection here. It can be done simply with invoking this method add authentication from the service collection. So here we go, builder.services.add authentication will add the respective services for authentication. Now into this method add authentication, we want to pass the argument saying how we want to authenticate the user, whether we want to use JSON Web Token or any other authentication standards. Before that, I want to discuss the involvement of the framework middlewares in this process of identity solution. Now, when it comes to an ASP.NET Core web application, whether it is an MVC or Web API, both the incoming request and the outgoing response must go through some established middlewares inside the project. In this given illustration, you could think of these vertical blocks as different middlewares. Now, if you are not familiar with ASP.NET Core middlewares, you could go through this in-depth article. I have given the link in video description. So basically, there will be a chain of middlewares in between the actual request and the destination of the request, and there will be similar middlewares while returning the response. You could think of these middlewares as a common necessary interruptions for the proper working of the app. And each one of them works one after other in sequential order. So the order does matter. Now inside this table, you could see the available built-in middlewares in ASP.NET Core framework. Some of the middlewares will be added by default into the project and rest of them could be added as per your requirement, like these authentication and authorization in this project. Both of them should be added into this project with the respective method. Now just now we have added the required services for authentication purpose, and through this method we will say how we want to configure the authentication. But it won't add the necessary middleware into this application. For that, we have to invoke the use method useAuthentication. That will add the necessary middlewares for the authentication purpose. And that also must be done in the proper order. Among the middlewares that precede the authentication middleware, the CORS middleware is the closest one in sequential order. I will explain what is meant by CORS and how the middleware works in a bit. And then we have to add the middlewares for authentication and then authorization. So this order must be followed. So that's what I have shown as an example inside this illustration. This order must be followed. And most importantly, all of these middlewares must be added before adding the web API methods inside this project. We have to do the authentication or authorization before accessing the protected resource. Then only we can protect the resources from unauthenticated user. So first of all, let me start with adding the middleware for CORS, which is not necessary for this web API project. But to make you understand the concept very well, I will add the respective middleware. Some of you might have experience with configuring this CORS middleware. CORS stands for Cross Origin Resource Sharing. So by default, a web API project will deny a request coming from a source having a different domain name or different port number. In order to allow such a request from a different port number or URL, we have to add that into this CORS middleware. For that, all we have to do is from this app object, we can invoke this method app.useCORS. Through the arguments of this method, we can grant access for external applications to consume this web API. So we have added the respective middleware into the web API project here. Now for this demo project, we don't have to configure this CORS middleware. So I will wrap it inside a region like this. Let it be config CORS. Already this program.cs file is cluttered. We'll organize everything into respective files and folders in next video. So let me forward this region here. So here we have added the CORS middleware, and then here we have the method invoked by default inside this project useAuthentication. It will add the necessary middlewares for the authorization, which we have not discussed yet. We'll do that in an upcoming video. We have added these two middlewares, CORS and authorization. In between, we have to add the middleware for authentication. For that, all we have to do is just invoke this method useAuthentication. So with this method add authentication, we will add the necessary services to the app and configure how we want to authenticate the user. And such a logic will be executed with the adding of this middleware here. In between these middlewares, CORS and authorization. So hope you understood. Now with this method add authentication, we want to specify how we want to authenticate the user. Now, before getting into the implementation, I think it would be more helpful if we organize the terms that we already heard of related to authentication or authorization. I mean the standards or protocols that we most often use for authentication and authorization. At the same time, we are not getting into any details of these standards here. In this tutorial, we are only discussing JSON Web Token. I just want to make you aware of the alternatives that is related to this topic. In that way, you will not get frightened when you hear these fancy terms while you research the topic further. So first of all, we have OAuth 2. So that is a standard, which is then extended into this OpenID Connect, in short OIDC. And then we have JSON Web Token. So these are the most commonly used or most well-known standards for authentication and authorization. Apart from them, you could see Security Assertion Markup Language, SAML, System for Cross-Domain Identity Management, and then we have finally Web Service Federation. If you want to know more about these standards, I have given the link to this article in video description. You can go through them and could study more about these standards. In this particular tutorial, we are using this standard JSON Web Token, in short pronounced as JWT. Now regarding this topic of authentication and authorization, you could see various categorization like based on different aspects of the process like password authentication, then biometric authentication, etc. and etc. All of the categorizations are done based on different aspects in the process. Okay. Now, before discussing JWT or JWT authentication in detail, we should be familiar with one more type of categorizing authentication methods. They are session-based or cookie-based authentication versus token-based authentication. These two types of authentication are more common when it comes to implementing authentication, particularly in web applications. While going through the documentation itself, you could see the terms like token-based authentication or cookie. So learning how these two types of authentication works and how they differ will give you a clarity on this topic of authentication. So first of all, we have session-based or cookie-based authentication. Now in this whole illustration, this part here represents the client browser. And here we have the server side consisting of the web API or the MVC application along with the database. And in between, you could see the request and response in between these two parties. So first of all, here we have the post request trying to log in into the web application here. And inside the server, the given credentials are verified. And if there is a user with given credentials, a new session record will be saved into the database, proving that this particular user is successfully authenticated into the system. As a response to this request, the session ID which we have saved into the DB will be returned. And then inside the browser or client side, the received session ID will be saved to the browser cookie. Inside your browser, if you open the developer tools, you could see application. Inside that, you could see the cookies related to each website. So for this application, this much cookies are saved. Similarly, the session ID will be saved to the browser cookie, and from there onwards, in order to access any protected resource from the web application, we have to pass the session ID as the cookie inside the request. And then inside the server side, before the request reaching its destination, the in-between authentication middleware will verify whether this session ID is present among active sessions. So while considering active sessions, the expired sessions will be ignored. And if this verification is successful, the request will reach up to its destination, and then the proper response will be sent back to the client side. So that's how session-based or cookie-based authentication works. Now when it comes to token-based authentication, it is stateless, meaning that there is no involvement of database like we've seen in cookie-based authentication. There is no record saved in database proving that a particular user is successfully authenticated to the system. Now JSON Web Token Authentication or JWT authentication comes under token-based authentication. So here it goes. First of all, the user makes a post request trying to log in into the web application. And then of course inside the server side, the given credentials must be verified with already stored users inside the solution. And if this verification is successful, then a token will be generated. In case of JWT authentication, the token is called as JSON Web Token, in short JWT. The same token will be returned as a response to the request, and then inside the client side or browser, the JWT will be saved somewhere persistently. That would be outside the browser cookie. Most often that would be the local storage inside the browser. You could see that inside this developer tools itself, local storage and all the local storage key value pairs for this website could be seen here. So a key value pair like this will be used for saving the received token as part of a successful authentication here. And from there onwards, in order to access any protected resource from the server side, we have to pass the JWT inside the authorization header of the request, in which along with passing the JWT, we have to pass the prefix bearer. Don't worry about this, we'll be showing you how to send this JWT inside the request authorization header. This part of validating token signature is really important because inside this token-based authentication, there is no involvement of database to check whether this user has already authenticated to the system or not. We could discuss that in a bit. So if the token signature is validated successfully, then the request will get the access to the protected resource, and then the respective response will be sent back to the client side or browser. So that's how cookie-based authentication and token-based authentication differs. Inside the cookie-based authentication, a record is saved to the database proving that this particular user is successfully authenticated to the system. When it comes to token-based authentication, there is no involvement of database for storing the record proving that a particular user is successfully authenticated to the system. So that's one of the important difference between these two types of authentication. Along with them, you could see the difference in how the session or token is saved inside the browser, and from there on how it is passed to the server for accessing protected resource. Now let's dive deep into JWT authentication and let's see how it is able to do everything without saving any state of the authenticated user in a database. For that, here we have the official documentation of JSON Web Tokens. So first of all, we'll discuss how the JSON Web Token is generated. And then we can discuss how it is getting validated in the subsequent request. So basically, JSON Web Token has three parts: header, payload, and signature. And each of these are separated with a dot or period symbol in between them. So typically the header part consists of two properties or two informations. First of all, we have sign-in algorithm and then the type of the token. Since we are dealing with JSON Web Token, we will set it as JWT. And with this property ALG, which stands for algorithm, into that we have to pass the algorithm that we used for encrypting this signature here. I will explain that in a bit. So most often these two algorithms are used, SHA-256 or RSA algorithm. In a bit we'll be explaining how this algorithm plays a role in generating the JSON Web Token. So the first part of the token will be base 64 URL encoded version of this JSON object here. The intention or meaning of the URL encoding will be discussed later. And then comes the payload. So basically payload consists of claims. Claims are statements about the entity that would be the authenticated user and then some additional data about the token that we are generating. For example, inside this payload you could see that the admin property is set as true, meaning that this logged user is an admin, and then here we have the corresponding user ID from the database, and here we have the full name of the logged in user. Along with these user related claims, you could see claims like this IAT. Those are the statements or additional information about the token that we are generating. You could see such predefined claims inside this documentation here. If you want to know what this means, we can search for IAT. See, it represents the time of issuing the token. So such informations or statements will be there inside the payload. Now before adding the payload into this JSON Web Token, the same will be converted into base 64 URL encoded version. In between both of these header and payload, there will be a period separating them. And finally here we have the important part of this JSON Web Token, signature. Inside this signature, we are not hiding any extra information than what we have inside this header or payload. So this signature is generated using the algorithm that we have passed inside the header here. See, the same algorithm is used here for generating this signature, SHA-256. So this encryption algorithm will take this part here from the beginning of the token up to this second dot here will be taken as the input for the encryption, and then the same will be encrypted with a secret key that we have passed to it. Now as you know, the JSON Web Token is generated as a result of successful authentication of a user. So this secret key must be private and should not be exposed to anyone outside the server. As long as the secret key is not available, no outsider can modify or break into this generated JSON Web Token. More about that could be discussed once we generate the JSON Web Token. So back to the project. At present we only added the services for authentication here, and the corresponding middleware is added here with the app object. So before generating the JSON Web Token, we have to configure the authentication with the authentication standard we are using. So that would be JSON Web Token. For that, we have to install the NuGet package to work with JSON Web Token. So right click on packages, then manage NuGet packages. Inside this browse tab, search for this NuGet package, which I have given in the video description. You can copy paste from the Authentication JWT bearer. Let's install the package. So the installation is successful. Now back to the program.cs file. Now to this add authentication method, we'll be passing a lambda expression like this. Now inside this lambda expression, we are going to pass authentication options. So these are the available authentication options that we can pass to the Lambda expression. So here we go, x dot default authentication scheme, and then we have default challenge scheme, and then we have the default scheme itself. All of these three schemes will be assigned with JWT. So here we go, JWT bearer defaults dot authentication scheme. Now it's necessary to know what is a scheme. It's a combination of authentication handlers and their configuration. So you could think of these authentication handlers as methods defining how to handle a requirement in the process of authentication. And along with its configuration options, together is called as schemes. So back to the authentication options here. Along with the schemes that we are passing here, you could see other schemes inside this table that the ASP.NET Core Identity is asking for. So this default authenticate scheme expects a scheme containing the basic core handlers related to the authentication process. And then this default challenge scheme expects a scheme containing handlers defining how to handle an unauthenticated request. And apart from these two schemes, authenticate scheme and challenge scheme, you could see other schemes inside these authenticate options. So for such schemes, we have not specifically set the scheme. So by setting this default scheme, all of such other schemes will be assigned with the scheme that we are passing here. So all of these schemes and rest of them is assigned with the JWT authentication scheme. So everything will be handled by JWT authentication scheme itself. In certain applications, there could be multiple authentication standards used. In those situations, these schemes could have different values or different schemes assigned to them. Now, we need to register the JWT scheme with necessary configurations. For that, we have to invoke this method, add JWT bearer method. Now, inside this method, we have to configure or tune the JWT authentication as per our requirements. For that, here we have the second Lambda expression. First of all, we will say whether we want to save the token or not. Since we are going for JSON Web Token authentication, we will set it as false. Now we are going to specify how we want to validate the token for subsequent requests after a successful authentication. As I said already, how it works will be discussed once we generate the JSON Web Token. For now, let's configure how we want to validate the token. For that, we can assign this property token validation parameters. Now, in order to validate the token signature, we have to set this property as true. And to do the same, we need the secret key of the encryption. This secret key, we need this for validating the JSON Web Token. So here we go, issuer sign-in key is equal to, this option only accepts an instance of this class symmetric security key. Inside that, we want to pass the encoded version of the security key. Now we'll save the security key inside this app settings.json file. So here we go, app settings. Inside that, we'll have this secret key JWT secret. Now this secret key must be having at least 32 characters. For this demo project, we have set the requirement of the secret key itself as the secret for the JWT authentication. So make sure to provide the secret key having 32 characters. Now let's pass the value of this key to this method getBytes. So here we go, builder.configuration. Now let's provide the path of the key. So inside app settings, we have JWT secret. Now you could see a green squiggly line here saying there is a possibility of null inside this key. We already provided a value for this key. So at the end of passing this key, you can add this exclamation mark like this. So in this way, we can turn off the possible null error warnings when you can always ensure a value in the context. So first of all, we have reset this Boolean property saying that we don't want to save the JSON Web Token after its creation. And with this property, we have specified how we want to validate the JSON Web Token in the subsequent request after a successful authentication. We want to validate the signature of the token, and here we have provided the necessary key or secret key for the validation purpose. we'll be discussing how the signature is getting validated once we generate the token. Now it's time to create a web API method for login or sign in operation. So we'll be making a post web API method with this URL. Inside the body of the request, we'll be passing the email address and the password of the user. And inside the web API method that we are about to create, we will check whether there is a user with the given credentials inside the DB with the help of ASP.NET Core Identity User Manager. And if it is successful, we'll create the JSON web token, and finally from the web API we'll be returning the JSON web token to the client side. So at present, inside this program.cs file, here we have the web API method that we have created for user registration. So let me copy this and let's forward this web API method, and just beneath that we can add this web API method with this URL sign in API/sign in. And here we have the lambda expression to handle the request. Now let me copy paste the parameter from this user registration web API method. We need the user manager. In order to receive these two credentials, email address and password, we are going to create a model class like we have done for user registration. For that, let me copy paste this. This is login model. Inside that we only need email and password. At present, this program.cs file is messy. We will be organizing everything into respective files and folders in the next video before authorization. Now instead of user registration model, we have login model, and let's rename this parameter also. Now with the help of this user manager, we have to find if there is a user with the given credentials or not. So here we go, user is equal to user manager dot find by email async method can be called. Into that we can pass the email from the model that we have here. Now since we have an async method here, we can prefix the method with the avoid keyword, and that requires an async method just before this lambda expression here. Now we have only checked if there is a user with the given email address or not, because we can't check for the received password inside the DB. During the user registration itself, the password is hashed. So for that, we'll be using a separate method. So here we have the if clause. First of all, we'll ensure there is a user with the given email address. And here we'll do the password comparison. For that, we can invoke this method check password async. As a first argument, we have to pass this user object itself, and then we have to pass the password that we have received through the request body. Now this method will check whether the given password is the correct password for the user. Now if it is successful, we'll handle the request inside this if clause here. Else we'll return a bad response. So here we go, return results dot bad request. Inside that we can pass this object message is equal to username or password is incorrect. Now inside this if clause, let's go ahead with generating the JSON web token. For that, first of all, I will save the encoded version of the secret key that we have here into a variable. So here we go, sign in key. Now actually we are already done that inside this JWT configuration options here. So let me copy this and pasting the same here. Now we want to describe the token that we are about to create. So that would be deciding what are the claims or informations that we want to add into the payload. Once the header and the payload is available, the signature could be generated or encrypted with the algorithm that we have specified here using the key that we have saved inside the app settings.json file. So all we have to do is just describe what are the informations or claims that we want to pass into the payload of the token. So here we go, token descriptor. Into it, we'll be assigning an instance of this security token descriptor. Now through this property subject, we can pass the custom claims like user ID, role of the user, etc. and etc. So into this property, we'll be assigning an object of this class claims identity. And the constructor of the class expect an array of claims. For now, we only have a single claim. Inside that, we'll be providing the user ID. So here we go, new claim. The name of the claim will be user ID. Now the user object corresponding to the credentials that we have here will be inside this user object here. From that, we can access the user ID. And let's convert it into string format. So at present, we only have this custom claim. As per the future requirements, we can add necessary claims into this token generation process. Then after the custom claims, we can set the expiry for the token. Instead of add days, let's invoke add minutes method. So the newly generated token will expire after 10 minutes. And finally, with this property sign-in credentials, we have to pass the sign-in key that we have saved inside this JSON file, along with the algorithm that we want to use for the encryption of the signal part. So here we go, new sign-in credentials. As a first parameter, we have to pass the sign-in key here. Then as a second argument, we can pass the algorithm, security algorithm. This particular algorithm could be passed, SHA-256 signature. So here we have passed whatever we needed for the payload, and here we have passed the sign-in key along with the algorithm that we want to use for the encryption of the signature. Finally, in order to create the token, first of all, we want to create an instance of token handler. For that, we can create an instance of this JWT security token handler. Now let's create the token, security token. From this token handler, we can invoke this method create token. Into that, we only want to pass the token descriptor that we have created here. Now finally, in order to convert this token into a serialized format, we'll create a variable token. So this is the actual token that we want to pass as a response to the post request. All we have to do is from the token handler, we can invoke this method write token. Inside that, we can pass the security token here. Now all we have to do is just return the response within this OK method. We have to return it within an object token. Now let's build the project. Now back to the Swagger UI. So here we have the post request that we have just created, API/sign-in. Now click on try it out. Now let's pass the user credentials of the user that we have created in previous video. So email is equal to email@gmail.com. And then we have password. The correct password was string, then a pound symbol or hash symbol. Now in order to test the working of this web API method, let's try with wrong credentials. So I will set the password as string. Click on execute. So here we have the bad request with the message username or password is incorrect. So that is from this else block here. Now before passing the actual password, let me increase the expiry time using the method add days, so that we can avoid the situation where the generated token will get expired before explaining the related topics. So let me build this project again. So that will reload this API Explorer here. Let's try to make the same request, but this time we are providing the correct credentials, email, then password. Click on execute. Boom. See, here we have the JSON web token. Now let me copy paste the same into a notepad for closer inspection. So first of all, we have the header, then payload, then finally signature. All of them are separated with a dot in between them. So here we have successfully implemented the web API method for login or sign-in operation. First of all, we have checked whether we have a user inside the stored list of users with the given credentials here. And if there is such a user, the web API will create the JSON web token and it will be returned as a response back to the caller. So inside the previous illustration about token-based authentication, we have completed this part here. Now, if you are making this request from a client-side application, you have to store the received JSON web token somewhere persistently. Most often, the browser local storage is used because we need to pass the same for accessing any protected resource from there onwards. And once such request asking for protected resource reach in the web API, the passed JSON web token will be validated inside the server side. So that's what we are going to discuss in rest of this video. we'll be making a request for accessing protected resource along with passing the JSON web token once we discuss the authorization. So that will be discussed in the next video. In the next video, we'll be discussing how to organize everything what we have inside the program.cs file. Now let's see how the token or token signature is getting validated inside the server side. For that, I will make use of this debugger inside this official documentation. Now let's switch into the dark mode. So this is how it works. If we provide the receive token here, the containing header and payload will be decoded here. And with this last portion, we can verify the signature. So let me copy this and pasting the same here. Let's remove the new lines that we have added. Now you could see the decoded header and payload of this token here. Here we have the algorithm that we have used, SHA-256, and here is the type of the token, which is JWT. Inside the payload, you could see the ID, user ID that we have passed inside the web API method. You could verify that from this user's table here. See, the same ID is the pass into the payload. Then we have the expiry time as per the configuration we have given during the token generation process. Now other than those two, we have IAT, which stands for issued at time. NBF stands for not valid before, which exactly have the same data that we have inside the IAT, meaning that this token is not valid before the issued time here. Okay. Now you should be careful while describing the token like we have done here. Whatever we pass inside the claims or payload can easily be decoded because the URL encoded format of the payload is directly added to the token. Now the process URL encoding is the process in which the characters that we have is converted into a format that can be transmitted over the internet. To be specific, the converted output from the process should be safe to pass within the query strings of the URL. So that involves replacing special characters in the data with respective encoded versions. So make sure to avoid passing crucial data through the payload. It could be easily decoded by pasting the JSON web token inside this part. Can also be decoded easily with the respective decoding methods. For example, in case of JavaScript, if you pass this payload here into this method ATOB, we will get the decoded version. Let me try that here. ATOB, inside that let's pass the string. So here we have the encoded version of the payload. Now let's execute the method. You see here we have the string version of the payload that we have passed inside this JSON web token. You could see the same here also. So that's how easy it is to decode the URL encoded version of the payload or header. Now the actual protection is inside this third part here, signature. Now like we have discussed previously, this signature is formed by encrypting this part here from the starting of the token up to this second dot here. And for the encryption process, we have passed a secret key. Now during the process of validating the token signature, the signature part will be recreated by encrypting this part with the signature that we have saved inside this server side here. Now let me illustrate the same with this debugger's third part here, verify signature. Inside this part, this much portion will be taken as the input for the encryption using this algorithm SHA-256 using the secret key that we provide here. So whatever secret key you provide here, this much portion will be encrypted with the key that we have provided here. And the result will be updated in the signature part of the token. And here you could see the feedback saying signature verified. So meaning that this signature is the exact encryption of this part with the given secret key here. That's exactly how we create the signature. Now whenever we change any of these values inside this header or payload, you will get this feedback invalid signature. Meaning that encrypting this much part with this given secret key does not match this signature here. So that's how the debugger validation feedback works. Let me undo the change that I have done. Now let's go ahead with the actual procedures involving invalidating a token signature. Inside this notepad, we have the original JSON web token. So during the verification of the signature inside the web API, this much part will be encrypted with the key that we have saved inside this app settings here. and then the resulting signature will be matched with the received signature. Let's see them in action inside this debugger. For that, first of all, I will clear this signature. Now let's copy paste the secret key inside this debugger here. Now this signature will be matched with the received signature. See, both of them match each other, and thereby the verification of the token signature is successful. The user will get access to the protected resource, and if needed, they can make use of the information that is received through the token payload. Now let's see how much safe is a JSON web token. Suppose a hacker got this token from someone successfully authenticated to the system. They can easily decode the payload, and if they want to change any of the information like user ID, role, or whatever it may be, they can do it without a problem inside the payload. But during the token verification process, it will be caught because inside this signature, the original payload is encrypted. So anyone outside the server can't do anything without the secret key that we have saved inside the web API. So this token is protected by itself because there is a signature of the actual data passed through the token. So hope you understood how the token signature is getting verified while accessing a protected resource. Now this will be done in action while doing the authorization. As I said already, we'll discuss that in the next video. In the next video, we'll be discussing how to organize everything inside this program.cs file into respective files and folders. That's really important because already this program.cs file is messy. So that's it guys, you can download or clone this project from the GitHub Repo link given below in video description. If you found this video helpful, please consider appreciating the effort through likes and shares. And if you haven't subscribed to the channel, please consider doing it now so that you will get the notification for future uploads. So that's all for now. See you in the next video.